Hey, what's going on guys? Isaac Frank here again, and in this video we'll be talking about functions. A function is a group of reusable code which can be called anywhere in your program. This eliminates the need to repeat yourself when writing code. You can define it in a function, you can add it in a function block, then this function will have a specific task. So you can call this function anywhere on your code without having to repeat the lines of code you wrote. This video explains and also teaches you how to write your own functions in Solidity. Before we can be able to use a function, we need to define it. To define a function, this is a basic syntax of defining a function. You make use of the function keyword and you give it a name. Then you add a parenthesis. In this parenthesis, you list the parameter list. Also, you give it a visibility. And next, you give it the type of function you want your specific function to be. And this other stuff we'll add to the function is optional. You give it a modifier. Don't worry, later in this video we'll talk about modifiers. And then you give it a return statement telling the function that you're expecting a value from it. And in the parentheses, you list the data type you expect to get from this function. So give this strings, and then you input your blocks to define the function. For better understanding, we'll create a function and I'll explain the function name, the parameter list. I'll explain the rules guiding a function. First, we'll talk about function name. So now we have to give this function a name, but there are some rules you need to know about function names. A function, the name of a function cannot begin with a digit. So we can't say something like this. This won't work because a function can't begin with digits. Also, a function can't accept special characters like the @ sign or any special character including the quote sign. You can also divide the name of a function using underscore or camel case. For instance, you can do something like this. You've made this look readable, so any other developer developing with you will look at this and understand what the function does. Also, you can make use of underscores. This also explains what this function is for. So these are the basic conventions you need to know about function. I will just create a simple addition function. So we'll name this add numbers. Add nums. I'll just leave it like this. And now we'll go over to the parameter list. In between the parentheses, you have to list parameters this function accepts. You have to list values this function accepts. So this function will just be adding two numbers. So to list parameters a function accepts is just like declaring a variable. So we want the variable this function to accept is a type of integer, and we'll give it a name, a unique name. We'll call this a. And now to add a next argument, a next parameter for this function, you separate each parameter with a comma. So we'll separate this, and when we attempt to do to this function accepts more than one argument. So the next argument, the next parameter we input, we'll give it a type and also a unique name. So we'll give this stay integer and also we'll call this b. Next thing is the visibility. In Solidity, there are 4 visibilities available for your functions and your variables. So I'll list them up here. We have the private visibility, we have the public, the external, and the internal. So these are the 4 visibility we have in Solidity. So when declaring the function, after the parameters, you have to give this function a visibility. How visible should this function be? The private visibility makes this function to be only called in this contract. If a contract inherits this contract, it won't be able to call this function. This function can only work in this particular contract, in this very contract, this function's contract we created. So that's what private does. It makes a variable or a function to be private to a particular contract. the public visibility makes this function to be visible to everybody. This function can be called outside this contract. Another contract can call this function, and also this function can be called by contract that inherits from this contract. That's what the public does. It makes the function or a variable to be public to the whole world, to the whole Ethereum system. Next we have is the external visibility. The external visibility can only be called from a third party. The contract where the function is defined and can't call it. Even if a contract inherits this very contract, the inherited contract can't call this function. Next we have is the internal functions or variables. So the internal keyword, the internal functions, and the internal variables, these are variables that are just they can be called from just inside the contract which they are created, and derived contract or the child contract. So for our addition function, I don't think we have much to do. We'll make this public visibility type. So next is the type of a function. So the type of a function, there are two types of functions. We have the view functions and we have the pure functions. The view functions ensures that let me quickly list it here. The types, we have the view and the pure. So we have the view and the pure functions. The view functions tells Solidity that this particular function will not modify the state. It will write to the contract. It will just read from the contract. While the pure function, on the other hand, tells Solidity that this function will not read or write to the function, to the contracts rather. The view functions is a read-only function. The pure function has nothing to do with the contract. It doesn't read from the contract, and also it doesn't write to the contract. We need to know the type will make this function, because right now we are getting the argument from the user or from any function that calls this function. So we are not reading from the contract. We are not reading a variable from the contract. We're not reading a state variable from the contract, which means the view is off the table. Also, in addition, we are not writing to the contract. We're just adding two numbers given to us. We're just adding two numbers given to us here and here. So we are not reading from the contract. We are not also writing to the contract. So we'll make this function a pure function. Then we'll come to the modifier. The modifier is a special kind of function. It's a rule you create. There are also some built-in modifiers like the payable modifier, which tells the contract that a function accepts payment. But you can declare your own modifiers, which we'll talk later in this video. Just like a set of rules you want the contract to adhere to, like prerequisites the contract should adhere to before running. So that's what modifier is, which we'll discuss further in this video. So now that's out of the way, we'll talk about the return statement. So like I said earlier, this return just tells the function that you're expecting a value from it. Without a return statement, this function can return a value. So we need to tell the function that we are expecting a return value from it, and also what type of value we are expecting from it. So you use the returns. Remember, returns with an S. Returns, and in the parentheses you give the value, the data type you're expecting from this function. So this will be int, which will be integer, and then we can add our curly braces. So now this is it. We've created a function that accepts two parameters, two arguments, and is public, can be called from outside this function, and is also a pure function, which means it doesn't write or read from this contract, and returns an integer. Let's store this in a local variable. The result of our addition, we'll store it in a local variable. We'll just return the results. We can't have a return statement in a function without having a returns. What would I call this? A returns function, because this return works with this. So yeah, we told it to expect a uint. Right down here, we were returning the sum. We are returning a uint. We can return an int to give us an error because we specified here that we needed an integer. So we'll just return this. Right now, we've created a function that accepts two numbers and also return the sum of the number. So to see this, we'll deploy this contract. And right here, if you can see down here, it's accepts A and B separated by commas. So we input 1 plus, we're using the comma to separate the values 9, and we add the numbers. See, we get a 10, which is the sum of these two numbers we input here, which means our code is working. At times, you will not want the user, which is someone from outside this contract, to be able to call this function. Maybe you have a function that does stuff and you try to add numbers together. You want this function to only be used inside your contract. We'll change the visibility to private. Okay, we'll change the visibility to private, and watch if we should run this, deploy this contract again. You can see no function is displayed here because this function is not private. When we talk about inheritance, we'll make use of internal and external functions. We'll make this private because we don't want a user from outside to call this function. And we'll create another function that calls this function, because right now we've declared a function but we've not called it. We can call it through the deploy tab, but mostly at times you create functions to use in your contract. So I'll show you how to call functions in your contract. To call a function, I'll create a function here. Name of the function, I'll call this call sum. Then this function will not accept any parameters, and also the visibility type of this function should be public, so we can call it from our deploy tab over here, or we can call it from outside this contract. And the type of this function, since it's not reading and it's not writing to the contract, we can make this a pure function. And also we return an int. So sorry, I forgot this. So in this function, what was wrong? In this function we need, sorry, see this error, this should be a return, not a return. Okay, so we need a, we give it a value of 9, and we need b, give it a value of 10. We've declared some variables over here, and now we need to call this add numbers to add these two numbers. So to do that, we can simply, since this returns a uint, we can store it in a variable sum, and to call the function, you call the name of the function, add nums, you put in the parentheses. If your function, then you in the parentheses you list the parameters which your functions accept. In our function, it accepts 2 parameters, so we have to add 2 values to this function. We can add the a and b. So, and then finally we return the sum. So this function calls add numbers. After add numbers does the addition, it returns the sum, the result of the addition, which we assign to this variable here, and finally return it to the user so the user can see the output. So let's try deploying this contract again. And as you can see, it's just one function that is showing because this is private, so only this public function is showing here. We'll call this sum. As you can see, we get 19 because this evaluates to 19. So that's a way to call a function. So now we've talked about the aspects, all aspects of a function. Let's talk about modifiers. So like I said earlier, modifiers are used to modify, oh, I don't like using the word modify and modify, but I used to modify the behavior of a function. Let's say to add a prerequisite to a function. So we'll just close this, and to define a modifier, you make use of the modifier keyword. So I'll do this modifier, and you give this modifier a name. So I can say cost, and this modifier, you can give it a parameter or not, just like a function, it accepts parameter. So I'll give it the price. I'm writing a price, and then in the query braces, the price don't have a data type, sorry, my bad, and then a query braces. So in the modifier right now, we've declared a modifier, we have to give it some rules it should take for the function to take, and we want the user to be able to call this function only if he sends, let's say, 1 ETH to this contract before he's able to call this function. So to do this, I would have used some statements, built-in statements in Solidity, like the require and the set, but we've not talked about them, so I'll just make use of an if statement. So we check if the price. So we check if message.value, which means whatever value, whatever amount the user is sending, if it's greater or equal to the price, then we'll use this. So what this does is telling the modifier that once this condition is true, it should continue the block of the function. So once the condition is false, it can't continue the block of the function reverts. It sends the money back to the user. But with this here, once the condition evaluates to true, the function is then being called. So to do this, I'll create a state variable, a mapping, and this mapping should point to from an address to bool. We call these users. So we've created our modifier. It's time to create our function. I'll create a function. So we'll call this register. Doesn't take any parameter, and it's a public function. This function will be able to write to the contract, so it's not a view function and it's not a pure function, so the data type should be empty. And next we define the modifier. So a function can take as many modifiers as possible. So the first modifier we'll give this function is the inbuilt modifier, the payable modifier. So this lets the function to be able to receive money, to receive currencies from a user. And then we'll give it the next modifier, which is our modifier. So we'll give it a cost modifier. So we say this function should cost the user 1 ether. So these ether are inbuilt in the Solidity. They are the currency unit in Solidity. They also have the days unit in Solidity, which is the seconds, the days, I don't think there's a month. Let me see if there's a month in Solidity. No, there is no month, but there's seconds, there is days. So this ether is Solidity inbuilt. If you go to the deploy tab here, okay, here as you can see, Solidity supports the way, the GUA, the FINI, and the ether. So you can make use of any here, the way, and I think Solidity supports the FINI also. Yeah. So, but we are asking the user to pay 1 ether to be able to call, to be able to register. So the user must pay 1 ether for this function to run. And I don't think we have to return anything. No, let's not return any value. So this function doesn't return, it just asks the user. So in this function, we want to add the user to the users table, so that we'll know the users are registered. So we'll add the users. Whoever called the function, the sender, the address, because the address points to a bool, and it should equal true. So how this function will run right now is, once the user calls this function, it goes to the cost. Then once it reaches the cost, it checks if the money the user sent is equal to the price, which we pass in here, which is 1 ether. So if the money is equal or greater than the price, then the user is being added to our database, our mapping. So so now the function has been created and the modifier has been created. Let's try running this function to see if we did anything right. So we'll deploy this contract. If you check here, our value is 0. Let's just change this to ether. Our value is 0 ether. So once we send, this function should not run. It should not be able to add those to the database. Let's see. Okay, let's make this in a way that we can see what's going on. Let's make this public so that we can see the users. Okay, or just create a function for, okay, let's make this public so we can see the user. I will deploy this contract again. Now let me copy my address. You see it's false, and once we try registering using 0 eta, the transaction will run, but once this condition doesn't pass, it will revert, but it's not an error, it runs, because if statement doesn't return an error. And then once we try checking it again, it's also false. But let's try giving this contract 1 eta as the contract requires. And let's register again with 1 eta, which we have sent to the contract. So once we try getting the user, you see it's now true. So we are telling the modifiers are just a prerequisite, telling the function things it needs and stuff it needs to work. So if we haven't put the eta sent to this contract, this function will never be called, will never be added to the database. So that's what modifier does. It gives a function a kind of set of rules to follow. With the modifier out of the way, we'll be talking about function overloading. There are certain times where you, like in this our function where we are adding numbers together, you might want to add more than 2 numbers together. You might want to add, let's say 3 or 4, but you don't want to make this compulsory to the user to input 3 or more numbers. In programming in general, there are something called the optional argument. That is the process whereby you give your parameters a default value. Like we can assign a default value to this. So defining a default value to this, and in other languages, some languages supports this. And so the user, if the user enters just a single, let me just expand this. If the user enters just a single argument, it gives it to the a variable, and the rest will still be 0. So our addition will also work. But in Solidity, that doesn't work in Solidity. So we have to find a way to make this work, which is where the function overloading comes in. So just clear this. So this function accepts 2 arguments. What if you want to accept 3 arguments? You want to a function that adds 3 numbers together. It wouldn't be ideal to create a new function for let's just create a new function. Create a new function like this, and then give it a new name, and so on. Keep creating different functions for this. Function overloading is the process of creating multiple functions with the same name. So creating the same function, as you can see, we get a function has been defined already. So to get over this error, we'll add a new argument to this function. So in here we add C to it. So right now we've created 2 functions of the same name but different arguments. So if a user passes 2 arguments to our function, it calls this function. If the user passes 3 arguments to this function, it calls this function. So see this in working, and we just let me duplicate this. It should be called 3. Okay, let's add a new number here. Let's add Alright, let's deploy this contract. We'll call which pass 2 arguments. So as you can see, Solidity knew that it was supposed to call this function that accepts just 2 arguments. If we call some 3, Solidity also knows that since the value accepts 3 arguments, Solidity look for the function where it accepts 3 argument, which is this, and it calls this particular function. So this is the process. This is called function overloading. Solidity also provides some group of functions, inbuilt functions, known as the cryptographic functions, and these functions are used when developing a project. So we'll not make use of it in this video. Maybe in the future videos where we might build something, then we can make use of it. But these functions are basically for, let me just close this. Alright, these functions are useful when developing projects. They are the SHA-3. Mostly these functions are used to hash an input. So whatever we pass to the function, they are functions. So whatever we pass to the function, it returns the hash to us. So these are basically the cryptographic functions. And next we'll talk about here are the fallback functions. And this should be the last in this video. The fallback functions, they are special kind of function in a contract. They have the following features. It's only called when a non-existent function is called on the contract. So right here we only see functions that are declared, but if we are making use of some library or third party to interact with our contract, trying to call a function that doesn't exist returns an error, except you have a fallback function. So once there is a fallback function, once you call a function that doesn't exist in the contract redirects that call to a fallback function. It is required for a fallback function to be marked external, given the visibility of external. And a fallback function has no name, at least as of 0.5, Solidity version 0.5. A fallback function was a function without a name, and also it cannot return any value. So fallback function doesn't accept a return statement and a return stuff like that. It can be defined just once in a contract. So this contract cannot have more than one fallback function. It can have just one fallback function. Also, a fallback function, if it's not marked payable, using this payable modifier, if a fallback function is not marked payable, the fallback function can receive error. So if your contract is a contract that does transaction, you want to mark your fallback function payable so that maybe you can revert the account back to the user, or maybe you can call a particular function to handle the money the user sent. So a fallback function, if it's not marked payable, it cannot receive error, which means it throws an exception. So how do we declare a fallback function? Before Solidity 0.6, I guess, to declare a fallback function, you make use of the function, then the parentheses, you mark it external and give it a payable. This was how to declare a fallback function pre 0.6 Solidity, which made it to be a nameless function because it had no name. But since Solidity 0.6 upwards, as you can see, it changes here. Instead of making use of the function keyword, you make use of the fallback. So now this creates a function, a fallback function, and as it's payable, if a user calls a function that doesn't exist from our list, automatically it gets called to here. And if a user sends a currency to this contract, this fallback function in here, you can decide what to do with this contract. You can revert, and you can revert the money back to the you can revert, which means send the money back to the user, or you can transfer the money to your wallet or stuff like that. So this was as of 0.6, earlier 0.6. This was how to declare a fallback function, and we only had this fallback function. But from the 0.6.4, I guess, Solidity introduced a new fallback function called the receive. So the receive fallback function has the exact rules as a fallback function. It's required to be marked external. It's called when non-existent functions are called, and also if not marked payable, it should throw an exception. But one thing with the receive function, to declare a receive function, you use a receive keyword and external and mark it payable. So you make use of the receive keyword, and since it's a function, it doesn't accept and it doesn't return any value. And it's required to be an external visibility, and make it payable. So this function only runs when the user sends a currency, which is when the user sends a message of value to this contract, or the user called a function that doesn't exist. Automatically, if you have a receive function, the receive function is called. Why the fallback function right now? How the fallback function works is, if you call a function that doesn't exist, even if you don't give it any money, if you don't send any money, but the function doesn't exist, the fallback function gets called. The receive function only gets called when money is involved. So you call a function that doesn't exist, but money is involved in it, so the receive function gets called. But you call the function that exists, but there is no money involved, the fallback function gets called. But if you don't have a fallback function, if you don't have a receive function, and you send you call a function that doesn't exist and money is involved, automatically the fallback function is called. So the fallback function is the last function. Like if no other function can be called, including the receive, then the fallback function is then called. So the fallback function is the function to be called when no function exists, and if the transaction has to do with money, it will also check if receive function exists. Once receive function doesn't exist, before it calls the fallback function. If there's no receive function and the transaction contains money, it gets called. But if they receive a receive function and the transaction doesn't contain money, the fallback function gets called also. So the receive function is only there to receive data, to receive currencies from whoever sends the transaction. So these are the two fallback functions in Solidity. So that's all on this video talking about functions. In the next video, from the next video onwards, we'll enter into the advanced sections of Solidity, where we'll talk about constructors, we'll talk about inheritance, abstract contracts, interfaces, libraries, events, error handling, and so on. So thank you guys for watching. See you next time.